Hello, and welcome back to Machine Arena. Today, we'll explore a multi-billion-dollar industry that's not just about making new tires, but also giving old ones a brand new life. So get ready to see some incredible machinery and ingenious processes that are shaping the future of transportation. We begin deep inside a modern tire remolding and recycling facility, where old, worn-out tires are given a second chance at life through a remarkable mix of human expertise and advanced machinery. Each day, truckloads of used tires arrive at the facility. These come from auto shops, fleet garages, and tire collection centers. Upon arrival, the tires are unloaded and sorted manually by trained technicians, each wearing protective gloves and scanning for signs of structural damage. Every tire is closely inspected, and decisions are made based on experience and precision. Can it be remolded, or is it destined for full recycling? For tires that are still structurally sound, the remolding process begins. The first step is cleaning. Tires are placed on conveyors and pass through powerful washing stations, where rotating brushes, hot water, and high-pressure jets scrub away years of dirt, oil, and road grime. A clean surface is vital to ensure proper bonding in later stages. Next comes buffing, a crucial and highly technical step. Skilled operators load each tire onto motorized spinning drums, where abrasive grinding wheels remove the old tread layer. The buffing must be exact. If too much material is removed, the tire becomes unsafe. Too little, and the new rubber won't adhere properly. Machines control the pressure and depth, but human oversight ensures perfection. Once the casing is smooth and uniform, it moves to the building station, where the real transformation begins. Here, a new layer of high-grade rubber is applied to the outer circumference. This is the new tread, the part that will make contact with the road. Using precision-guided machinery, the tread is wrapped around the tire, aligned perfectly, and pressed tightly. Then comes curing, where the remolded tire is placed into a mold inside a curing press. With intense heat and pressure, the new rubber permanently bonds to the casing. At the same time, the tread pattern is imprinted into the surface, just like in a brand new tire. This process, called vulcanization, hardens the rubber and gives the tire its final strength and shape. Once cured, the tire cools and enters quality control. Trained inspectors run their hands over the surface, checking for imperfections. The tire is placed on a balancing machine and rotated at high speed while sensors look for wobble, uneven weight, or air bubbles. Only those that pass every test are approved for resale. These remolded tires will soon be back on the road, used on trucks, tractors, buses, and even everyday cars. It's a cost-effective and environmentally responsible option for consumers and businesses alike. But what happens to tires that are too damaged for remolding? They take a different path, the recycling line. In another area of the plant, these non-reusable tires are fed into massive shredders, towering machines with rotating steel blades that tear them into strips and chunks. Operators monitor the input flow, adjusting speeds and feed rates to avoid jams and maximize throughput. These chunks move down conveyor belts into granulators, where they are ground into smaller pieces. High-powered magnets extract any remaining steel, while air separators remove nylon fibers and debris. What remains is crumb rubber, a clean, granular material ready for new uses. Now, instead of discarding this material, the factory turns it into raw input for new tire production. The crumb rubber is blended with virgin rubber, carbon black, sulfur, and various chemical agents in enormous Banbury mixers, giant steel vats that churn the ingredients into a consistent, moldable compound. This stage is all about chemistry, balancing elasticity, strength, and durability. Once mixed, the compound is rolled into sheets or extruded into precise rubber strips. These become the components of a new tire: the inner liner, the steel belt layer, the sidewalls, and the tread. In the assembly zone, advanced tire building machines take over. Each component is applied layer by layer onto a rotating drum. Robotic arms position and press the parts into place with micrometric precision, while technicians oversee the process and make real-time adjustments when needed. This creates what's called a green tire, a fully assembled, uncured tire. It's then placed into a curing mold, where high-temperature steam vulcanizes the rubber. The pressure imprints the final tread design and hardens the structure into a durable, road-ready tire. After curing, the tire is cooled, inspected, pressure tested, and scanned for any defects, both by eye and with automated systems. Only tires that meet strict standards for safety and performance are approved to leave the facility. The final result? A brand new high-performance tire made partially from recycled rubber, but built with the same precision and durability as one made entirely from new materials. This process shows how far technology has come. It's no longer just about waste management. It's about creating value, closing the loop, and producing quality products while preserving natural resources. In the end, what once was considered waste becomes a new beginning, rolling back onto the road with strength, reliability, and purpose. In the world of industrial tire recycling, it all begins with raw force, breaking down some of the toughest products ever made. Heavy-duty shredders are the core machines used to recycle tires that can't be remolded. These aren't ordinary tools. They're massive, steel-toothed giants capable of tearing through reinforced rubber and embedded metal like paper. At some facilities, the process begins with a fully automated conveyor system. Stacks of discarded tires are loaded at one end and fed smoothly into the shredder. With robotic precision, the conveyor controls spacing and timing, feeding one tire at a time into the spinning jaws of the shredder. Inside, sharp rotating blades bite down and crush the tires into rough, manageable strips. But not every factory has high automation. In more hands-on environments, workers operate in teams, using physical strength to lift and roll large tires directly into the shredder's hopper. These are demanding tasks, often involving tires from tractors, trucks, or industrial machines, each weighing hundreds of pounds. Timing and coordination are key to keeping the process safe and efficient. In other advanced facilities, forklifts or tire handlers are used. Operators maneuver heavy tires into position and push them into place using mechanical arms or clamps. This method is especially useful for oversized tires like those used in mining or construction. Once in place, the machines do the rest, tearing, grinding, and preparing the rubber for further processing. No matter the method, conveyor, manual labor, or forklift, the goal is the same. Reduce these solid, heavy objects into pieces small enough to move to the next stage. Whether it's for rubber mats, asphalt filler, or the early steps in tire remanufacturing, it all starts here with the brute power of industrial shredding machines. Some tires are simply too big for conventional machines. Off-the-road tires, commonly used in mining, agriculture, and heavy construction, can weigh over a ton each and stand taller than a person. Recycling them requires a different approach. At specialized facilities, the process begins with skilled forklift operators. These workers carefully maneuver oversized tires using heavy-duty lifting equipment. Each tire is clamped, lifted, and positioned with precision in front of powerful dismantling machines. Once in place, a hydraulic extractor takes over. The machine drives metal arms into the thick tread, gripping and separating the rubber casing from the steel rim. This is a delicate step. Despite the massive size of the tires, precise force is needed to avoid damaging the valuable steel components inside. After disassembly, the tire carcass is moved to an industrial shredder designed specifically for large-diameter rubber. These shredders feature extra-wide feed openings and reinforced cutting blades capable of slicing through dense material. The shredded pieces are then conveyed onward for granulation, where they are processed into crumb rubber, just like smaller tires. Specialized OTR recycling prevents these enormous tires from being stockpiled or abandoned. With the right machines and skilled operators, even the biggest tires can be broken down safely and turned into usable material once again. Before a new tire ever touches the road, it begins in the digital world. At the start of the process, a computer simulation runs side by side with factory operations. On one screen, engineers use advanced software to design and test tire structures virtually, adjusting thickness, tread pattern, and internal layers to meet specific performance demands. On the other screen, we see the physical process unfolding inside the plant, where high-tech machinery brings those digital blueprints to life. In the factory, raw materials are delivered to automated stations. Bales of natural and synthetic rubber are weighed and blended with carbon black, silica, oils, and chemical additives. These ingredients are fed into powerful mixers, called Banbury mixers, that blend and heat the compound until it reaches the ideal consistency. This rubber compound is then shaped into various components of the tire: inner liners to hold air, body plies for strength, steel belts for stability, and the outer tread for traction. Specialized extrusion and calendaring machines produce each layer with exact measurements. Throughout the entire process, the work is closely monitored by trained operators and senior technicians. They check material temperatures, layer alignment, and thickness to ensure everything matches the design specifications. Every machine has a digital interface displaying real-time data, which workers use to make precise adjustments. The parts are now ready to be assembled. At the tire building station, multiple layers are applied to a rotating drum, each added in a specific order, pressed together under controlled tension. This forms what's known as a green tire. Not yet cured, but fully shaped and structured, the green tire is placed into a curing press, where heat and pressure trigger the vulcanization process. This transforms the soft rubber into a durable, elastic form. At the same time, the tread pattern is molded onto the outer surface. After curing, the tire is removed, cooled, and tested for quality. Visually inspected and scanned by advanced equipment to ensure structural integrity and performance. From virtual design to final inspection, the manufacturing of a tire is a seamless blend of science, precision, and human expertise, working together to produce a product that's ready for the road ahead. As technology continues to reshape modern manufacturing, the tire industry is no exception. In this segment, we enter one of the most advanced areas of the production line where automation meets precision in tire building. Here, towering robotic arms and high-speed assembly machines take over what was once a labor-intensive process. Rubber layers, steel belts, textile cords, and bead wires are delivered to fully automated workstations. These materials are assembled with minimal human handling, applied layer by layer onto a rotating drum by robotic systems programmed to maintain exact positioning and pressure. Each movement is controlled by onboard sensors and artificial intelligence. These systems monitor real-time variables like rubber tension, alignment, and thickness. If any deviation is detected, the line automatically pauses or corrects itself, ensuring every tire is built to the highest standards without the need for manual adjustment. While the machines do most of the physical work, skilled technicians remain essential. They oversee the systems through digital control panels, perform calibrations, and respond instantly to any alerts. Their expertise bridges the gap between software and machine, making sure the entire line runs smoothly and safely. What makes this automation truly impressive is the ability to build different types of tires on the same line. Whether it's a light passenger tire, an agricultural tire, or a heavy-duty industrial model, the machines adapt instantly by changing configuration settings. No lengthy downtime required. This level of automation significantly reduces material waste, improves product consistency, and boosts output. With fewer defects and tighter tolerances, tires last longer and perform better on the road. It's a glimpse into the future, where data, robotics, and skilled labor work hand in hand to produce high-performance tires with unmatched efficiency. A process that once took hours now happens in minutes and with greater precision than ever before. We've just completed a remarkable journey, from worn-out rubber to cutting-edge tire technology. Whether it's through remolding, recycling, or high-speed automation, this industry keeps the world moving. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more deep dives into industrial innovation, right here on Machine Arena.